In this video, we're going to do just a few more practice problems with the multiplication and addition rule for probability. So here are a couple problems below. I encourage you to try these out. Grab paper, pause, try them one by one, and then we will talk about each of the solutions. Okay, suppose a homework assignment has 4 multiple choice questions and each have 6 possible answers, A, B, C, D, E, F. If you're purely guessing, what is the probability that 1, you get all of them right, 2, you get all of them wrong, and 3, you get at least one right? So for each of these multiple choice questions, we've got 6 possible answers, A, B, C, D, E, and F, and we assume that only one of them is correct. So, suppose that D is correct for the first one. So the probability of getting one of those problems right is 1 out of 6. Now, what's the probability of all 4 of those being correct? So that's the probability that it's, let's say, R is right or correct. So R and R and R and R. That's each of those problems is correct. So this is the multiplication rule, right? The probability that we get the first one right and the second one right and the third one right and so on. So that's probability of R times probability of R times probability of R times probability of R, because this is an and. I got the first one right and the second one right and the third one right and the fourth one right. We saw that each of these has a probability of 1/6. So this is 1/6 times itself 4 times. So we could write that as 1 over 6 to the 4, or we could write that as 1 over 1296, 6 to the 4th. What's the probability that we get them all wrong? So again, if we're thinking about just one of these problems, A, B, C, D, E, and F, and we're saying that D is correct, then 5 out of 6 of those possible answers are incorrect. 5 out of 6 are wrong, right? So what's the probability that we get all of them wrong? We'll use the same idea here. This is the probability of W and W and W and W. The probability of the first one's wrong and the second one's wrong and the third one's wrong and the fourth one is wrong. So that's equal to probability of W times W times W, the probability of W times the probability of W. Each one of those individually is 5/6. So 5/6 times 5/6 times 5/6 times 5/6. And so that is, if we multiply 5 by itself 4 times, we get 625. If we multiply 6 by itself 4 times, we get 1296. When you multiply fractions, you just multiply across the top and multiply across the bottom. And so that is the probability of that. What is the probability that you get at least one right? So here's a place where it's easier to think about the complement, of this event. So probability of at least one right. What happens if you do not get at least one right? So what is the complement of that scenario? So this is going to be equal to 1 minus the probability of the complement. We just have to think about what the complement is here. If you don't get at least one right, what happens? If you don't get at least one right, then you must have gotten them all wrong, right? All answers wrong. So if it is not the case that you got at least one right, then you must have gotten every single one of them wrong. We already calculated that above. This is equal to 1 minus this. We've already calculated that, 625 over 1296. And so we could, if we're subtracting fractions, we need a common denominator. So that's 1296 over 1296 minus 625 over 1296. And then we just need to subtract above. And so we're left with 671 over 1296. If you roll two 8-sided dice, what is the probability that the first is an even number and the second shows a number less than 3? So, and we're going to be using the multiplication rule here. So, probability that the first is even and the second is less than 3. So what is the probability of that event? That's the probability that the first one is even, and so times the probability that the second is less than 3. So now we can think about each of those individually. The probability that the first die is even is 4 out of 8, or 1/2. The probability that the second die is less than 3, so that could be a 1 or a 2, and there's 8 possibilities altogether, so this is 2 out of 8 is the probability of this, 2 out of 8. When we multiply fractions, we multiply across the top, multiply across the bottom, so we could write this as 2/16, or we could, do some cancellation right off the bat. We could cancel the 2 in the top with a 2 in the denominator, and that's 1 out of 8 is this probability. Next, if you roll two 8-sided dice, what is the probability that the first is an even number or the second shows a number less than 3? So this is the probability the first is even or the second shows a number less than 3. And so this is, by the addition rule, equal to the probability that the first is even plus the probability that the second is less than 3 minus the probability that the first is even and the second is less than 3, because otherwise we're counting that possibility twice. So the probability that the first die is even is, well, we could either write it as 1/2 or we could write it as 4 out of 8. Since we're going to be adding and subtracting fractions, I don't want to have the reduced form. So I'm going to write this as 4 out of 8 plus the probability that the second die is less than 3, a 1 or a 2 out of 8, 2 possibilities out of 8, minus the probability that the first is even and the second is less than 3. That is what we already calculated up here. So this is 1/8. This we already calculated in the last problem. And so when we add and subtract those fractions, 4 out of 8 plus 2 out of 8, 6 out of 8 minus 1 out of 8, we get 5 out of 8 as our final answer. Next, if you roll three 8-sided dice, what is the probability that not all of the dice show even numbers? So probability that not all 3 dice are even. It's a common mistake here to say, okay, that means all 3 dice are odd. I want to find the probability that all 3 dice are odd. Note that is not the complement of the event, all 3 dice are even. So if not all 3 dice are even, what are some possibilities? We could have a 1, a 3, and a 5, and then, it's true that not all 3 dice are even. But we could also have something like, this is an 8-sided die, so we could have 7, 6, and 4. And that still falls into this category of not all 3 dice are even. So let's just rephrase this in a way that's more familiar to us. It's not the case that all 3 dice are even. So that means that this is the same as the probability that at least 1 die is odd. And now when we think of something being at least 1, that might trigger in our mind that we want to think about the complement. So if it's not the case that at least 1 die is odd, then all of the dice are even. So the complement of this event, the complement is all dice even. So what we want to find is 1 minus the probability of the complement, 1 minus the probability that all dice are even. And so this is equal to 1 minus probability that all dice are even. That's probability of the first die being even, and so multiplication, the second die being even, and the third die being even. And so that's equal to 1 minus probability the first die is even, that's 4 out of 8, or 1/2. And second die is even, 4 out of 8, or 1/2. And third die is even, 4 out of 8, or 1/2. So this is 1 minus 1 over 2 times 2 times 2, that's 8. And so this is, we could write this as 8 out of 8. 1 is the same as 8 out of 8. We need a common denominator when we subtract fractions. So 8 out of 8 minus 1 out of 8, that's 7 out of 8 is that probability. Lastly, there are 8 green marbles and 7 red marbles in a jar. If you select 3 marbles one at a time without replacement, what is the probability that all of them are green? So we've got 15 marbles altogether. So this is the probability of green and green and green. And our previous problems were independent, so they were about dice and coins and stuff like that. So those were independent events. The likelihood that one die is an even number has no effect from the previous die being even or not. Whereas here, because we're talking about not replacing these marbles, that means that these are not independent events. So we have to say, okay, the probability that the first marble is green, okay, times the probability that the second one is green given the first one was already green. So times the probability the second one is green, maybe I'll call that G2, given that the first one was green, times now the probability that the third marble is green given that the first one was green and the second one was green. So that's what I'm trying to find. So this is the probability the first marble is green. Well, in the beginning, there were 8 marbles that were green in the jar containing 15 marbles, times the probability that the second marble is green. Well, now there are only 7 green marbles left in a jar of 14 marbles, times the probability that the third one is green. Again, I've got 6 marbles left out of 13. So now I just need to multiply the fractions. Again, I'm multiplying across the top, multiplying across the bottom. If I wish, I could do some cancellation before I do my multiplying. So 7 out of 14, I can turn this into 1/2. Let's see, 6 over 15, I can take a 3 out of each of those. So I could make this a 5, and I could make this a 3, or I could make this a 2. I could also cancel this 2 that's in the numerator with this 2 that's in the denominator. And so what I'm left with is 8, I didn't do any cancellation to that, divided by 5 times 13, that's 65. 8 out of 65 would be my final answer. Or if I'd done this without any cancellation, I would just be multiplying 8 times 7 times 6 divided by, in parentheses, 15 times 14 times 13. And if I did that, like say in a calculator, I would get a decimal answer of 0.123077. I could round that to 0.123. So that's our decimal equivalent, and we could write it as a fraction or we could write it as a decimal.